You're listening to Wurth Electronics What's Up Radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Wurth Electronic technical specialists who are going to shine a light on our topics like energy harvesting, wireless power transfer, EMI issues, and more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Wurth Electronics What's Up podcast. Well, today we are talking with one of our experts here at Wurth Electronic. Ben Arden is a business development manager for our electromechanics division and overall very knowledgeable go-to guru for all things connectors. Ben, thank you for joining us today. Now, I want to talk to you about Press-Fits. A few years ago, Wurth Electronic introduced their first line of these Press-Fit components, and now we have the entire REDCUBE Press-Fit line. What would you say the advantages of REDCUBE Press-Fits are?
Yes, the advantages of REDCUBE Press-Fit is a solder-free installation process, a very gas-tight seal, powerful electrical connectivity, and strong mechanical stability.
When you're talking about using the REDCUBE Press-Fits, where are you placing them? Where does Press-Fit really fit in on the board?
Press-Fit fits in any location where you're trying to bring a high amount of electrical current to a point. It also helps in making a good mechanical location on the board that is strong to support the board itself or another board attached to it.
Something you mentioned at the beginning of this interview, and we see it throughout the Wurth Electronic website. You mentioned one of the benefits to REDCUBE is that they are gas tight. What is gas tight, and what are some of those benefits?
Yes, during the cold welding process, two metal surfaces create a gas-tight connection. So by pressing the pin into the via, you are deforming the plating, but that plating is protecting the connection, the surface area, the exposed surface area, from foreign molecules, protecting it environmentally.
It seems as though REDCUBE could be used for different applications then. What are the different environment types where this would be beneficial?
This would be good for any environment that has a lot of vibration, an environment that has high temperatures and high electrical properties being transmitted from either wire to the board or board to board.
So it sounds like a lot of industrial applications would really benefit from the REDCUBE Press-Fits. But would we be able to use these Press-Fits with, let's call it a little bit more friendly of an environment or more of an office atmosphere?
Yes, that is possible. Anytime you are connecting the power from a battery to a larger battery to the circuit board, it might be ideal to use a press fit. The press fits are typically used in a system where the current is higher than 50 amps, but again, it has no damaging material on it like plastic, so that the metal can be in a rough environment.
Okay, you said up to 50 amps. Is that the absolute maximum power?
No, this is the minimum power. Our product can be used for any low current connection, but it can handle up to 500 amps. That is, with enough pins and enough surface area, we can achieve up to 500 amps.
Up to 500 amps seems like quite a lot. Are there certain certifications for these REDCUBE Press-Fit components, and are they UL certified?
Well, although we do meet a lot of industrial and industry standards, there is no specific certifications for these products. We have our reliability reports that identify environmental, mechanical, and electrical properties REDCUBE is not UL certified, and the reason is because UL is for safety rating, and this product has no plastics included, so it's not protecting any of the exposed metal. It's all metal. So UL certification is not available for this product.
So a lot of people out there have seen the video. We've seen the pictures of the REDCUBE Press-Fits, and you can even see pictures attached in this podcast, but it's a square peg, round hole. What is the reason for the square pin design?
Yeah, the square pin design is to ensure that we can align all of the pins properly, having enough tolerance to make sure that none of the PCB is damaged. The tolerance on a round pin allows us to have the angles of the pin to engrave into the via without having too much overlap. And the reason why we don't use circular designs is because those eclipse styles would only allow a small change in location to cause major effects in quality.
So with it being so small, when it's actually connected, would you say the surface area is sufficient?
That is more than sufficient. We actually are able to achieve more surface area on the corner of each pin added up through the thickness of the PCB than there is the amount of surface area of the cross section of the pin. So the amount is larger, and multiplying that by the number of pins, we see that we have a very large surface contact transmitting electrical current into the board.
Now, when we're looking at the different types of REDCUBE Press-Fits, can you describe them and maybe the reason behind these shapes? I assume they mean something.
Yes, there are different shapes on the top side, including externally threaded pieces, internally threaded components, and 90-degree or horizontal mounted components. So these all have different benefits in certain designs. But the other interesting thing is the bottom design. The design of the layout of the pins on the bottom of the REDCUBE also play an important role in how it performs mechanically and electrically. Again, we have to be cautious of heat development because that will decrease your current rating. And so the way that the pins are laid out is critical for achieving the right properties.
In your expert opinion, is there a favored pin layout that would be most beneficial or that you see more designers are gravitating towards?
Well, yes, the full pin pad layout is the most common. That is because you achieve the most mechanical stability, and you are able to get a very high amount of current. The circumference pin pattern, it can be going to be selected when a hole is placed through the component to attach your hardware to. And then the 2 rows is pretty interesting because that allows the most thermal efficiency, but at the highest current rating. So this is a component that is sort of, we're in between selecting the full pin pattern and the 2 rows. The top side, it is more common to see an internally threaded component being used because the hardware is actually irrelevant when it comes to the current transfer. You need the surface areas of the ring terminal or other component to be flush with the top of the REDCUBE to achieve the proper current.
You briefly mentioned the current values or getting the proper current flow a few different times for the different pin layouts. Why do we see change in current values on different pin layouts?
Yes, this is related to the derating curves of the products. All power products have curves that define how much current can be used at a certain temperature. And as the temperature increases, we decrease our current capabilities. And so the 2 rows of pins will be more thermally efficient than the full pad of pins. We are able to achieve a certain current value at a specific temperature differently with these 2 designs.
You said earlier that there is no plastic on the REDCUBE Press-Fits. They are completely metal. Does that mean that you are able to solder them?
The Press-Fits, no. The Press-Fits are not meant to be soldered. There are other components within the REDCUBE line that are designed for solder. What we see when we have tried to solder the Press-Fits is that we get a lot of cold solder joints. We get a lot of bonded joints. We actually affect or damage the plating. So it is not suggested to solder the press-fit components. The pressing action of forming the via to the corners of the pin is sufficient to hold it in place and to create the most current transfer.
We talked about the common environments where you can use these components, and you mentioned a lot about industrial applications. Do you have statistics or information on how much vibration these press fits are able to handle?
Well, yes, we have tests, mil spec tests that are done in line with these components to define or help identify what vibrations they are able to handle. Although those are only references to the components test, they are not certified in automotive or any other industrial certification for vibration.
So how do you actually choose the correct hardware?
Yes, selecting the correct hardware is important, not for the current transfer, but for the concern of corrosion. So galvanic corrosion is the effect you receive on 2 different metals touching each other. And if you choose the wrong 2 metals, you will have a greater chance of corrosion buildup. So being that the components are brass with tin plating, selecting the right components from the galvanic table is necessary.
Right, so you don't want corrosion, but is there a way you could still stack the items?
Yes, that is identified in our design guide. The stacking is, as I mentioned earlier, the stacking is where you would want the electrical surface to be touching the REDCUBE at the base. So your cable lug, for example, touching the REDCUBE, and then you can use a washer, a lock washer, and a nut in that order to properly secure to a threaded post.
Are you able to do that in a factory, or does all of that need to be done by hand?
Yes, well, this is a hand procedure. To install these REDCUBEs is done by hand. Although the presses that you have available will help you install these much quicker. So whether you go with a hydraulic press or a hand press could give you different amount of time to install the product. What you need to install the product is a press that is at least 2 tons of pressure, and you also require some type of anvil on top and a base. The base is required to have the ability for the square pins to travel into that base, because the recommended PCB thickness is between 1.6 and 3.2 millimeters. And these pins will exceed past the PCB, even with the 3.2 millimeter thick board. And so those pins drive through the PCB. They need to go into the support base on the bottom. We do offer a CAD file for this support base where we recommend that the customer prints with a 3D printer a support base that fits their needs. whether it's a pedestal or a specific design, we provide the dimensions for the proper hole size so that the pins can travel into the base.
Ben, from what you mentioned, it seems as though there are quite a few considerations that need to be taken in order to use these press fits. How difficult is it to create the PCB layout?
The PCB layout is not challenging at all. We do have the dimensions and designs for the PCB holes, the vias. There is a slight difference depending on how you are plating the PCB, but we do have those tolerances available in our design guide.
We have the vias, but what happens if the vias are not correct?
If the vias are not correct, there's also the chance that, in a quality situation, either the layout of the PCB can be incorrect or the component can have flaws. And whether one or the other has error in it, the ability to understand how much force is being applied when installing the press fit will help you identify if it's properly made. So if the PCB is out of line or the vias are too small, then there'll be a lot of force when driving in the REDCUBE press fit. Then you'll be able to have a second quality check by knowing the force that is required to install the part.
Now, are there any other quality checks that one should look for?
There is 2 quality checks. There's one by knowing the amount of pressure to install the REDCUBE part, and the second one is a visual inspection to see if there's any damage to the via or to the PCB. If there is damage to the via, where possibly the via has cracked, we have only seen a very small change in temperature rise if there's damage, around 0.8 degrees Kelvin. So this is insignificant for the amount of current and efficiency the part does have.
Now, earlier you mentioned the use of a hand tool. What else do you need, or what other tools are needed to install REDCUBE press fits?
Yes, it's not suggested or not recommended to install the press fits with immediate force. You want to use a press that applies pressure consistently until the component is properly seated into the PCB. So the 3 things that are required is the press, the anvil, the PCB that you're installing into, the support base, and the component, the REDCUBE component. From there, placing the part right over the land pattern, and then using the press to slowly install the part. So there is a recommended speed of installation to achieve good quality.
And finally, at the beginning, we talked about the environments where we could possibly use the REDCUBE press fits, but what applications would those components work very well in?
Yeah, the REDCUBE press fits will work very well with terminating a wire with a cable lug or ring terminal to the board. It will also help with alignment. You could possibly use 2 of these to keep alignment for a wire that's coming in. You could also stack 2 boards with these REDCUBE press fits to transmit current from one board to the next board. You could also you could connect bus bars up to these REDCUBE components because they handle a high amount of current. We've seen it even when you keep your PCB at a minimum, and you can also put a additional trace layer of copper bus bar pressed into these components. So pressing into direct copper is possible. We've also seen them used with fuses, connecting larger fuses, as well as any type of mounting. So these REDCUBEs, again, have great mechanical stability. So mounting and fixing to these is also very common.
Ben, thank you so much for joining us today.
Thank you, Amelia.
And thank you for listening to today's What's Up podcast. You can find more information about the Wurth electronic REDCUBE Press-Fit components by clicking on the link attached in this podcast, or visit Wurth Electronic online at www.we-online.com. You're listening to Wurth Electronics What's Up Radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Wurth Electronic technical specialists who are going to shine a light on interesting topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Wurth Electronics What's Up podcast.